Welcome. This series of videos is going to teach you your first lessons about coding, computer programming. I'm going to teach you the fundamental concepts that you're going to use over and over and over again, no matter what programming language you use, no matter whether you're on a PC or a Mac or a Chromebook. It doesn't matter. These concepts, they stay the same throughout all types of computer programming. So let's take a look right away. What you're going to learn really quickly, I'm just going to teach you a vocab word right up front, and that first vocab word for this class is algorithm. Okay, an algorithm is just a set of steps needed to complete a task, and as a coder, that's what you do. You write algorithms, right? You've got a challenge, something you want to happen on the computer, and you need to figure out what are the steps needed to make the computer do that. Algorithm isn't just a word for computing, just so you know. Like I wrote an algorithm here for getting out of bed. This is typically how things go for me. I open my eyes, I yawn, turn off my alarm, and then depending on what kind of day I'm going to have, I either smile or frown. I didn't put that in there. And then I sit up and I put my feet on the floor and I stand up, right? Those are the steps. I could break it down into smaller steps, depending on how you like to describe things. You might just say the steps for getting out of bed are get out of bed. And the difference here, the point I'm trying to make, is that different people are going to make different algorithms for getting out of bed. There are infinitely many algorithms that can solve every problem, both in computing and in real life. So what are the ingredients? What are the things we need to write an algorithm? Well, you're going to find out pretty quickly when going through your coding challenges that there are the same sorts of things showing up over and over again. So these three ingredients that I have here, believe it or not, if you have these three things available to you in a programming language, you can write an algorithm to solve any computing task. Okay, you can write every algorithm in existence with only these three ingredients. So the first ingredient is sequencing. A sequence is an order, like a set of steps in order, right? So how do I know what order they're in? In the algorithm for getting out of bed, I showed you the sequence because I numbered it. You can tell which to do first, right? If you do it out of order, it doesn't quite work as well, right? If I try to stand up without opening my eyes, I might fall over. Selection. Sometimes you need your program to make decisions, right? What if this is getting out of bed on a normal day, but what if there's a fire, right? I smell smoke. Obviously, the steps I'm going to take are going to be different in that case, right? I'm probably not going to stop to yawn. I might not stop to turn off my alarm. I'm just going to throw the covers off and I'm going to run and get my kids, etc. Point being, to have a better algorithm here, what I should really have is some sort of way to choose, right? Is there a fire? Is there a reason to do it slow or fast, right? That's called selection. You select a path for your code. And then finally, iteration. That's a fancy word for repeating things. When you iterate steps, you are repeating those steps, or you can repeat a set of steps. And with those three ingredients, you can do everything. So let's dive in. I'm going to take a look at Code.org's Accelerated Intro course. This is a great way to get introduced to these fundamental concepts of coding without having to get bogged down in the details of the programming language yet. We will learn those things, but a lot of beginners have a real hard time learning all the punctuation rules and stuff like that. So with these block-based coding environments, it's just a great place to sit down and learn these fundamental concepts. So right away, can you help me catch the naughty pig? Stack a couple of move forward blocks together and press run to help me get there. So the first concept demonstrated here is sequence. Okay, when I run this, if I hit run, it will do this first block first, and then it will do the move forward, and it will only do that once. And now if I put another move forward there, it will do that one next. So the way this block-based environment is set up, the sequence happens top to bottom. And that's quite simple. Sequencing is definitely the simplest of the concepts. So if I run this now, we're going to go through both move forwards, and I got the pig. Yay. I'm going to skip ahead a little bit here to the next concept. Once you get to bubble 6, they've got this new block here, a repeat block. Okay. Think about it to yourself. Pause the video if you need to. A repeat block, what concept is that out of these three? Is that sequence, selection, or iteration? Pause the video for a sec. Okay, well the answer is iteration. That's repeating. It's a repeat block. Iteration is just a fancy word for that, okay? The beauty of iteration is that computers are really good at it, right? Computers never complain. They'll do the same thing a million times in a row and they won't complain about it once. A human would never be like that. So it's nice for us because here's a situation where all I really need to happen is for the bird to move a bunch of times. 1, 2, 3, 4, 5 times. So I can just throw a move inside of that repeat block, use the power of iteration, okay, and it will repeat. Pretty simple. A concept thing to note, okay, that when you use a repeat block, that's actually called a loop. In fact, I'm going to add a new slide here about that. In programming, so that repeat block is called a loop, okay? And what a loop does is it actually changes the sequence. It's a special type of sequencing. It says to move forward, and then after moving forward, go back up to the top repeat block and check how many times to see if we need to keep repeating. So inside of the computer, JavaScript or the block-based coding here is keeping track of how many times it has looped, and it keeps counting down until it's over, and then it will go to the next block underneath the repeat loop. So I could, keep putting more blocks underneath there. Of course, if I do, I'm going to go over the limit for this challenge, but it is legal to do that. Okay, so that's iteration. Slightly more complicated example of iteration here. You don't have to repeat just one thing, right? If I just put a move forward in here, then the bird's going to move forward 3 times and that's it. Well, if I work this out, what I really need to happen is the bird needs to move forward twice. 1, 2, turn right, then move forward 2 more times, turn right, and then move forward 2 more times, and that will get me to the pig. And the reason I did this the long way right now without a loop is just to show you a great technique for determining what to put inside of a loop when you get stuck. Okay, so you'll notice here that we've got move, move, turn, move, move, turn, move, move, turn. Don't you wish there were a turn here? Well, you can put a turn there. Does it matter if the bird turns 1 extra step at the end of the loop? No. Well, now we've got 3 repeating chunks. Move, move, turn, move, move, turn, move, move, turn, 3 times. That's what I need in this repeat block. Okay, so if you code it without a loop, sometimes that can really help you to see what is the piece that's repeating. And you can iterate entire chunks of code, sometimes very large chunks of code, to get rather complicated tasks completed with very few lines of code. Okay. Last thing, we haven't covered one of them, right? We've done sequence and iteration. We haven't done selection yet. So let's take a look at that. Here is selection. It's this new block on the Code.org challenges. And the way that most programming languages implement selection is with an if. Okay, not all, but most programming languages use that. And what an if allows you to do is say, okay, only if this part is true should you run the code inside of the if block, right? Only if there's a path to the left should you turn left. If there's no path to the left, then why would you turn left? You wouldn't. But if there is a path to the left, then you should turn left, right? So this is a great show of how all three ingredients of our algorithms are in this one algorithm. We've got sequencing, right? It's going to go step by step. We've got looping, iteration, there's a repeat block there, and we have selection. Okay, so with very few lines, as long as we use all three of those ingredients together, we can get a great desired result so that the zombie can find the delicious flower, because of course we know that zombies eat sunflowers. That's all I've got for you. Welcome to your coding adventure. I really hope you enjoy it.